With every new generation of wireless networks, the result is faster speeds and enhanced functionality. With 1G, we got the first cell phones. 2G got us all texting each other, while with 3G, we got in line and started Googling. 4G gave us the speeds we enjoy today. But here's the catch. As more and more users come online, the demand for data availability is growing right alongside it. And at the same time this is happening, 4G networks are nearly tapped out. Enter 5G, which can handle 1,000 times more traffic than we see today, and which is 10 times faster than anything we've seen before. Let's put it into perspective. Imagine downloading an HD film in just a few seconds, or a rock being cut with precision in a mine in northern Sweden by a miner based in southern Sweden, or even a brain surgeon based in New York performing surgery on a patient in Berlin. The possibilities 5G is expected to bring will enable virtual reality, autonomous driving, IoT, and any number of other things that haven't yet crossed anyone's mind. So, what does 5G offer customers? To be honest, even the experts can't tell us exactly what 5G will bring when it comes to new ideas and connections, but they can point to 5 emerging technologies that lay the groundwork. And those are millimeter waves, small cells, massive MIMO, beamforming, and full duplex. Let's start with millimeter waves. Your devices, such as smartphones and tablets, use very specific frequencies on the radio frequency spectrum, typically under 6 gigahertz. But because carriers can only squeeze so many bits of data on the same amount of radio frequency spectrum, things are getting a wee bit crowded. And with more and more devices coming online all the time, the result is going to be slower service and more dropped connections. So, what is the solution? Establish some new real estate by broadcasting on shorter millimeter waves, those that fall between 30 and 300 gigahertz. This section of spectrum hasn't been used before, but utilizing it will mean more bandwidth for everyone. But not so fast. Millimeter waves don't travel well through buildings and other obstacles, and they tend to be absorbed by plants and rain. This is where small cell networks come into the picture. You've probably seen the huge, high-powered cell towers that wireless networks rely on. They're used to broadcast signals over long distances, but as we've already learned, higher frequency millimeter waves don't have an easy time traveling through obstacles. Small cell networks fix that by employing thousands of low-power mini base stations placed much more closely together than traditional towers. They form a sort of relay team to transmit signals around obstacles. Think of a basketball team passing the ball at high speed around their opponents. This would be especially helpful in cities where there are obstacles everywhere. Just say a user is walking down a city street, and when they turn the corner, they move behind an obstacle. Small cell networks would mean their device switches to a new base station with better range, allowing him or her to keep their connection. On to technology number 3, massive MIMO, or multiple input, multiple output. 4G base stations have roughly a dozen ports for antennas handling all cellular traffic. On the other hand, massive MIMO base stations can support around 100 ports, increasing capacity by a factor of 22 or more. But like with most technology, massive MIMO comes with its own challenges. Cellular antennas broadcast information in every direction at once, and all of those crossing signals run the risk of serious interference. Here's where we get lucky with beamforming. Beamforming is like a traffic signaling system. Instead of broadcasting in every direction, a focused stream of data is sent to a specific user, which prevents interference, increases efficiency, and allows stations to handle more incoming and outgoing data streams at the same time. Here's how it works. Just say you're walking down that city street we were talking about, trying to make a phone call. Your signal is bouncing off buildings and crisscrossing with signals from other users in the area. A massive MIMO base station receives all of these signals and oversees the timing and the direction of their arrival. It then uses signal processing algorithms to triangulate exactly where each signal is coming from and plots the best transmission route back to each phone. Sometimes it will even bounce individual packets of data off of buildings or other objects to keep signals from interfering with one another. The result? A coherent data stream sent only to you. Finally, there's technology number 5, full duplex. If you've ever used a two-way radio, you know that in order to avoid talking over one another, you have to take turns speaking, which can be a tad bit annoying for the more talkative among us. That is the exact challenge today's base stations face. The antenna can either transmit or it can receive, but it can't do both at the same time due to the principle of reciprocity, which is radio waves traveling both forward and backward on the same frequency. Think of it like this. A radio wave is a rush-hour subway train loaded up with data. The frequency it is traveling on is the train track. If there is a second train coming from the opposite direction along the same track, well, you're going to crash. Avoiding that crash has previously meant having the data streams put on different frequencies, but you can gain a lot of efficiencies by working around reciprocity. Using silicon transistors creates high-speed switches that halt the backward roll of these waves, sort of like a signaling system that reroutes trains or puts them on a sidetrack so another train can pass. Doing this means a lot more gets done on each track a whole lot faster. There's still a lot to be done in working out the kinks with all of these technologies. And let's be honest, all of 5G remains a work in progress because we've only just started our incredible 5G journey. But the good news is that technology is moving quickly, and ultra-fast 5G service has already arrived in some areas of Sweden and will cover the entire country within the next few years. So get ready to download that film in the blink of an eye, or maybe perform brain surgery in Stockholm on a patient in New York. Welcome to the wonderful world of 5G.